So, in case we talk about the different kinds of media or media access methods, so the first one that I would talk about of about which I have been talking about is my token ring or token passing. It can be said to be either token ring or token passing. Now, I hope you guys gained a little idea about this token ring algorithm. Uh, I hope everyone has an idea how it works. So, normally, uh, people they say that it works the best in a ring topology. In a ring topology. So you have several devices, and I hope you guys have understood how it works. But still, I need to discuss it once again. I'm really bad at drawing, but still, I will try my best. So I hope you guys understood. Now, what happens in this token passing? Uh, there is a 3-bit frame, 3 bytes frame. This frame is my token. This frame is my token, and that is having a 3 bytes. Now, this frame, it travels through the network. It travels through the network. Like this machine is having this token. Like it starts somewhere, and this machine has this token for some time. One concept again comes in, that is what we call as token holding time, the THT. The THT. This device will hold this token for a few uh, mm, seconds or milliseconds. That is the maximum of token holding time. So the maximum amount of time uh, this packet can be retained by any of the devices before it is uh, transferred to the next would be my THT. So I hope that is clear to everyone. Now, the next thing that happens is, in case this machine or this device holds this token, okay, beyond the token holding time. In case you hold this token for this 3-bit frame for more than the THT, it means you are going to transfer the data. So this token is taken back from the network, and it is held by this device. And instead of sharing the token, it will transfer the data. Right. So what the benefit would be, like, if the token is there on this network, no machine or no device can transmit its data. If you are having that token, only then you can send your data, else you cannot. So that is the benefit of token ring, that it makes the transmission completely collision free. Now, if two machines are transmitting data at the same time in a ring algorithm, it might get collided. So that is the mm, benefit of my token ring algorithm. Now, token ring, previously it started with only the ring topology, but later it was implemented in almost every kind of network, and it has been working very fine with all the different topologies. I hope that was clear to everyone. Now, when we have talked about this token ring, find who two are missing, Dhania. Fine. In this token ring, we might implement demand priority. I hope you guys understand the term called priority. They are absent, I understand, Dhanya. Nasiha and Sanjita, fine. Thank you. I needed the names. Thank you. So we can implement a demand priority. Now what happens is this token is moving around the network. Now we talked about a very small network. So it barely takes a few milliseconds or microseconds or even nanoseconds to run through the ring. Now, in case it is bigger, now what happens in case the token like takes more than a microsecond to transfer throughout the network? In that case, we might define this demand priority kind of algorithm. So now what happens with this demand priority is we implement it using something called smart hubs. Fine. So a smart hub will implement the priority. Now what happens is all the devices which need to transmit will send their requests to the hub, right? The hub will define which device will be transmitting, or it will define the permission for which device to be sent first. So suppose this device gets the priority. Now the hub defines that this device needs to transmit data first. The hub will grant it the token. So that token which was running throughout my network, it won't work like that now. So it will be defined and it would be transmitted by my hub. And that hub will define the priority and it will give the access of the token to that particular device. I hope that was clear. I hope that was clear. Someone has responded. Please repeat it. Okay, fine. Good. So we have the first thing that we talked about was my token ring algorithm or token ring technology. Now, what happens is we have a 3 byte long data packet that is called as my token, right? So that is containing that is 3 bytes long, and that is my token which is running throughout my network through every time. Uh, so as to find whether anyone is transmitting or not. So once this token or this 3 bytes long data packet is running on my network, no device does transmit its own data. Now it is running, so it goes to each and every device, each and every node, each and every terminal. Yeah, this packet or this token passes through each and every node and each and every device. Now, we need to have something called the maximum or total handling time. Now, you can hold this device, yeah, this token or this packet for a maximum of this THT or the total handling time. That might be 1 nanosecond or even less than that. In case you are having it for more than that, it means that you are going to transmit some data. So in case you leave this token before this TST, it means that the complete network is free. The cables are free. There is no one trying to send its data. Now suppose this device needs to transmit some data for some data. So what it will do is it will catch hold of the token. As soon as that token reaches it, it will take the data, yeah, take this packet or this token from the network, and it will keep it with itself. Now, others will know that someone is going to transmit the data since the token is not available on the network. So no one else will try to transmit its data. Right. Now this machine, this node will hold this token back, put that text or put the message on the network and leave the message. And once it has sent its data, it will put the token back once the receiver gets the message and sends the acknowledgement. I hope that was clear for most of you. I hope you understood the concept of this token. The next was like, suppose this was really good when we were talking about a very small network. Now, when we have a very really large network with a lot of devices connected to it, this technology was found to be not very comfortable working with. So, since we might have certain devices which are also trying to send data and they have higher priorities. So, for higher priority data transmission, this token ring algorithm did not prove to be very useful. So, what we defined was our demand priority kind of token ring algorithm. Now, in this demand priority, we implemented this token ring using smart hubs. Now, this token was handled by the smart hub centrally. So we have a central control of this token. Let me. So this token is not now on this network. This is being held by my smart hub. So what this smart hub does is it will get requests from all of the devices. Now all the devices send their request. And depending upon which device needs to send data first or which put its request first will be given priority, and that would be handed over with my token. Now this device will take care or take my token, keep my hold back my token till it has put the data on the network. Now once the data reaches the receiver, we get an acknowledgement, and now once the acknowledgement is confirmed, the token would be put back to my smart hub. So this is my demand priority kind of smart hub token ring algorithm. I hope that was clear. Find someone has put in something. Someone asked me if this hub is a physical entity. Obviously, right now we are talking only about physical things, not any logical thing. Fine. Any more questions? Now, the next technology that we have been using for even for longer duration of time, that is my CSMA. uh, My CSMA CD algorithm or technology. That is stands for Carrier Sense. Now the name is really important. Sorry, not Carrier. That is Carrier Sense Multiple Access and Collision Detection. It has really got a very big name, and that name does answer most of the things about this technology. Now, what happens in the CSMA technology is uh, a sense signal is whenever I want to, suppose multiple devices are connected. Now, whenever one of the device needs to send some data over the network, it will send a sense signal or a carrier signal. So this sense signal would be transmitted throughout. In case there is any kind of collision, it will receive the collision signal. In case there is no collision, it will receive the carrier signal back after the time duration or the time delay, whatever is needed to travel throughout the network. Right, you got this. I hope you got this, right? Suppose this is my network, right? I have various devices. So all these devices are putting their carrier sense signal over this network just before transmitting data. Now, suppose there is the length, here is a length. That length is L. That would be divided by the uh, that would be divided by the speed by which a signal travels. That is almost equivalent to the speed of light. So it will receive either of the two kinds of signals. One, those signals either get back. Now, after reaching the end, they might travel back and it receives the signal back. Or that means that complete path is free. There is nothing to worry about, right? So there is no signal on this cable. So this is fine. You can transmit your data. Now, the other can be like suppose this is trying to send its data, but meanwhile, this has started sending its own data. So what happens is its carrier will collide with this signal and you would receive a collision signal. I hope you got this. Suppose I am going from my home to my NSTI. So two things can happen. One is I go to my NSTI and once I am done, I come back. So that is one possibility. The other is I collide with some other, uh, might be, let me not collide. There is something which is not allowing me to pass. Might be there is a procession or some kind of things that is going on the road. So that does not allow me to pass. So what I do is I turn back. So these are the two kinds of signals it can receive. One is it will travel throughout and come back. So that is number one. Number two is it collides with some other signal, and once it collides, you would receive a collision signal. Now, in case you are receiving a collision signal, you will wait for some time before sending another carrier sense signal. So this is the whole idea behind the CSMS CD technology. Now, one more thing is there. Now, every time you are sending, now what happens is all the devices are sending their own carrier signals or send signals. Now, these devices also listen to these sensing signals. They will sense. Now, in case it understands that this machine, there is a carrier signal on this uh, mm, cable, other machines will, other nodes will refrain from sending their own carrier signals for quite some time. I hope you got the idea. Just confirm or we will again try to discuss this. Is it a protocol in the nodes? Yep, you can say, but better I won't call it a protocol. I would call it a method or an algorithm. Fine. So, what happens? Let us try to understand it once again. We have this network. Now, what happens is I want to transmit my data. What I do is I send a sensing signal. Now, this sensing signal will travel throughout the network, and in case it gets collided with some other signal, I would get a collision signal. And in case I get a collision signal, I will wait before I transmit my data again. Right. In case I find this carrier signal travels really well, so what I will do is I will start transmitting my data. I hope that is clear for everyone. The next step would be that I listen to all the signals. Now each device is can has access to the network, and any signal on the network is being received by everyone. Though I do not process it, but I can access it, right? I hope you guys got it. So what happens is, if I there is no signal on this network, no carrier signal I sense, and I have to transmit some data. So I put my carrier or my sensing signal on this network. I either receive that this network is free or it is busy. In case it is busy, I wait for some time. In case I receive this carrier signal of some other computer from some other node, I wait till I feel that it would be free now. Or if my carrier signal passes through all the nodes without any collision, I sense that my complete network is free and I start transmitting my data. So this is my carrier sense multiple access collision detection technology that we might implement. Now here we have carrier sense. We are sending carrier sensing signals. It will allow all the users or multiple users to access this physical medium. But this multiple access won't be simultaneous. Now, at the same instant, two devices cannot send their data. They can send their carrier signals, but not the data bits. This does understand, or this does make sure that it understands there is a collision. And in case, now suppose, even if my data signal is being transmitted over the channel or over the medium, and even then there is some kind of collision detection, there is a collision, this collision would be detected by my sender, and it will try to transmit the same data signal again once it feels that the carrier is this carrier or this network or this cable is free now. I hope this is clear, or this was really some jugular. Yep. Anyone having any kind of doubt, just let me know. Fine. So I hope this was clear. The next technology can be my very similar to my CSMA technology, that is my CSMA CA technology, that stands for Carrier Sense Multiple Access Collision Avoidance. Someone has put in something. What if two devices want to send data continuously? That is not possible. That is obviously not possible in with my CSMA CDMA technology. In any case, it is not possible. So I hope there is nothing that comes as a confusion for the CSMA CDMA technology. Similar is my CSMA CA technology, where what happens is once everything is almost the same. Now, once I have sensed that there is no one who is trying to transmit its data, I put a request. I put a request on this network that I am going to transmit my data. Now, in case I am transmitting my data and I have my request on my uh, network, no one else would try to send its data. And in this manner, I can avoid any kind of collision. I hope that was clear. Now we have the CSMA CA technology working on wireless networks as well. CSMA technology is normally used in most of my wireless technologies, while token ring and CSMA CD technology, they were implemented in wired mediums. But later on, CSMA CDMA was also implemented in many wireless device, yeah, like in wireless networks as well. But later, CSMA CSA technology took it over. Fine. I hope there are no questions to this. The next thing that we need to know or understand is my DNS system, domain name services. Now, anyone can help me with this domain name services. You guys have heard about this thing called DNS. I hope you have answered that in CSMA, CA, or CD, no two devices can never send at the same time. So, what do you think this DNS is? Yep. Whatever your ideas be, that is fine. That it would be fine if you are not correct. That is perfectly fine. Yep. I hope you guys got my question. Name of a website. Fine, good. Someone is trying to add something. Whoever is trying to write, I am waiting. With collision avoidance. No, that is fine, Pooja. You need me to tell this again. Is that so? So CSMS CD was where you are detecting any kind of collision. So what you do is you sense all the signals that are available, any carrier signal that is available. You do. Uh, you put in your carrier signals and just figure out in case anyone is there. So in case you find no one is there, you send your data on the network. Now, normally, if you have transmitted your data, no one else will. But even in cases we saw that other transmissions also started at the same time and data packets got lost. So we came up with this technology of avoidance. Now it again works in the same manner. It senses if anyone else is trying to transmit his or her data. Now once it feels like no one is going to transfer its data, it will hold the line. Putting a request signal, it will hold the line. Now once one of the devices is holding the line, no one else can put its data on that particular line. Now once the line has been holded by this particular device, suppose that is by putting up a request, this has hold the line. Now it will put a request, and once the line has been hold, it will put its data. And once the data reaches its destination, it will relieve the line. The whole line would be left. Now again, multiple devices would start putting their carrier signals, and that process again starts in the same manner. So that is how this CSMA CA technology works. It avoids any kind of collision by holding the line. I hope that was clear. Anyone has any question? Isn't that sufficient? I didn't get your question, Akash. I started with Pooja. Akash, you might unmute yourself and speak. Meanwhile, let's get started with the DNS, that is domain name service. Now, what happens in this domain name services is you the I hope we understand the domains, right? Suppose I am working on something called the Outlook. That is Outlook. So that is my domain, outlook.com, or anything else, whatever. So that is my complete domain. Now, this domain is human readable form. That is what I understand. Now, this is not machine readable format. Machines cannot resolve this. So, to resolve this and to make my machine understand the exact IP address of the domain provide, yep, exactly. That is fine, Pooja, but like Akash, I don't know what he wanted to say since I missed on whatever he wanted. Um, so Akash, you might put up whatever you want. So this Outlook.com that I am talking about, or might be we are on Hotmail.com, or Hotmail I use, that is why I take it. I have Facebook.com. So whatever it might be, these all are this Facebook.com or Outlook.com. They are human readable format. They cannot be understood by machines. So to make it available for the machine to understand, we use a domain name service. Right. So that converts into an IP address. I am not sure what is the IP address of Outlook.com. I really do not know. But it would be something like I have heard Google has 8.8.8. Let me try 0.8.8.8. Just let me see if that takes me to somewhere. That is trying to resolve. I don't know. Hmm. Hmm, this won't be. Now, this is the IP address of my router or my connection. So what we do is we convert the domain into an IP address. Now suppose Outlook has an IP address, suppose 192.0.1.1. So converting this or translating this outlook.com to this IP address or this IP address to outlook.com, name, system or services. I hope you guys were able to understand this. Yep, I hope you guys understood this much. So let us try to have it again. So this is my user. He connects first with the DNS server and then with the web server. Now, suppose he wants to go to a website like facebook.com, FB. He sends a request to the DNS server to resolve this domain into a IP address. So it gives you back the IP. Now, once you have the IP, you go to this is DNS server and this is the web server for the particular IP. Then you request the IP address and that IP address will provide you with the web page or the document that you are looking for. So this is how it normally works. Now, in the meanwhile, we might be having a DNS cache most of the times that are implemented so that you get whatever you want much faster. I hope you guys were able to understand this. Please confirm, or we need to talk about it again. Yep, please. Now, repeat it quickly. Fine. I will do that. So, you would find the DNS servers for me. Mm, yeah. So, my gateway is providing me with the DNS server. So don't think that we are implementing a completely different host resolver or the DNS resolvers. Those DNS servers are being provided by your gateway as well. So gateways can provide you with the DNS servers. So I hope you understood this. Hmm, I hope you got this. So again, whatever I told, I would be getting back to it again. But seeing this photo or this block, many of you might get confused like, where is this DNS? How do I get to this DNS? So basically, it is implemented by your gateway or your internet service provider, whoever it is. It might be Geo, it might be Airtel, it might be Vodafone, or it might be the service provider who is providing me with the services. Whoever it might be, they are providing you with the DNS resolvers. I hope that makes sense. In my case, you can see 192.168.0.1. That is the one, that is the in my gateway 192.168.0.1. My ISP that is having this IP address, he is providing me with the DNS servers, and my IP address on the network is 192.168.0. This is the address of my gateway or my service provider, and now this is taken automatically by this machine. Since whenever I connect it now, in case I disconnect and connect again, I might get another IP address. I hope that makes sense. Now, my DNS system, what it is, my machines cannot read the Outlook.com. They cannot take you to Outlook.com. So what they do is we convert the Outlook.com into a IP address. which is readable by the network and the machines. So what I do is I put outlook.com here, and this is resolved by the host. This host in turn tells us the IP address, and that IP address is what is requested from the IP address of the web server of the particular that belongs to that particular IP. The web server of that particular IP is connected, and the request is made, and in turn it gives you back the web page that you are looking for. I hope that was clear. Yep, Akash, I hope that was clear now. Obviously, mm, might be it was a little confusing. This DNS is being implemented by my gateway or my service provider. Hey, my gateway or my service provider is providing this. Now, in you can figure out the details of your network connection, right? Type in IP config, and that will help you with most of the things, but not everything. So you can check on the IP config all. I have two DNS servers connected. Most of the devices would be having two. So the first primary is 192.168.0.1. That is my primary DNS server, and 0.0.0.0 that I believe is nothing. That is my secondary DNS server. Now this DNS server is same as my default gateway or the my service provider. Now, so this is what I put, and this takes me to my service provider's uh, gateway. So I hope that makes sense that this DNS is what you can do is instead of going here, you might go on here. But the problem is this web page is not routed back via your DNS servers. No, it comes directly to you. And this DNS is only providing you with the name resolution. Now, once the name is resolved, you are requesting the website for the particular web page. So that makes sense. Uh, Now, any more questions anyone is having? So, anyone is having any more questions? Just let me know. Many of you have already left. So did you guys get, someone is trying to write in something. Yeah, great. So mm, that was again very long. In case you want, we can discuss more things, or we might